Hi, Annie.
Hi, Hannah.
I was wondering if you could look something up for me real quick.
Sure.
So I want to build cvc5 from source. Can you ask ChatGPT how to do that, please?
Yeah. How to build cvc5 from source. Wait, are you talking about the SMT solver?
Yeah.
That's easy. We don't need ChatGPT for that. I can show you, but before we do this, I'm wondering, why do you want to build cvc5 from source?
Oh, cool. So yeah, I made some small changes and now I want to see that they actually do what I intended. Are there other reasons to build cvc5?
Yeah. So that's one reason. Another typical reason is to enable some features that are not enabled in the default version that you download.
Oh, is that how I use tracing? I've been wondering about that.
Yeah, tracing is a great example for such a feature.
Cool. Okay, let's see how it's done.
Sure. So the first step is to go to cvc5.github.io. From here, we can go to the source code on GitHub and clone it. Let's do that, git clone with this address. While it's cloning, we can already go to a file called install.rst that has the compilation instructions. Note that this file also has a list of dependencies, and I recommend looking at this list. It's down below to see that you have everything installed before compiling cvc5. And let's go over the steps. Go into the directory, and the first one is configure. I strongly recommend running configure with auto download flag, auto download, because this will automatically download additional required software that you need in order to compile cvc5. So let's do that. This will be fairly quick. What this will do is that it will create a directory called build, to which you need to enter, and here you can just call make. Now, in order to make things faster, you can run make with the -j flag in order to enable parallel compilation, and you can specify the number of cores you want to use. Here I choose to use 7. Now, this is the first time we're compiling it on this machine, and depending on the machine, it may take several minutes. In order not to waste time, I have pre-compiled a version, the same version of cvc5, 5 just in another tab. So let me show you how it looks like after the make command finishes. So in the build directory, we have a subdirectory called bin, and there we have the binary, which is called cvc5. We can run it, for example, with the version flag just to get some version information about it. But more importantly, we can run it on an SMTlib file. Let's do that. There is a directory for examples, and in it we have many examples. So for example, we can take uf.smt, and when we run cvc5 on this file, we get that the result is sat. Let's just see how this file looks like. Just a typical SMTlib file for the theory of uf, and cvc5 solved it and saying that it is sat.
It's so much easier than I thought. Thanks for showing that to me. So you mentioned something about tracing earlier, though. How can I now output a trace for this example?
Yeah, so some people like to use tracing in cvc5 just to get some internal information from the solver run. And in cvc5, this is done by the -t flag. And after -t flag, you can specify a name of a trace. For example, theory check. But since we configured only with auto download, tracing is not enabled by default, so we don't have it in this compiled version. If we want to enable tracing, then when we do configure, in addition to auto download, we need to add the flag tracing. And there are plenty of other features that are added that way, like Python bindings, Java bindings, and more, that you need to specify in configure time. And once you do that, it will recreate the build directory and then you need to enter the build directory and make again. Once that's done, you will have a binary that supports tracing in this case. But again, in order to not waste time, I happen to have another version of cvc5 in another tab that supports tracing. Let's see how this would look like. Build bin cvc5 examples API smtlib and we'll do it with -t theory check. And now you can see that in addition of the final answer, which is sat, we have some internal messages from the run of the solver that relate to the theory of UF.
That's awesome. I can't wait to play around with options of the configure script. Where could I find more information about this?
Yeah, generally you can go to the documentation on our website, cvc5.github.io.
Thank you, Yanni.
Thank you, Hannah.